All right, so as we can see from our graph, the square root of x minus 1 moved 1 unit to the right. All right, so I can say right 1 unit. That's of course on the x, which is therefore going to make my translation x minus 1, and nothing happened to the y. I could also write it using a subscript, negative 1 on the x, 0 on the y. And when I draw that graph, I'm going to go 1 unit to the right and draw my curve like that. Okay? All right, so let's come down here. There's this sentence here to fill in. Remember what lies in the equation, and lie as in does not tell the truth. Okay, so we want to notice that in 4, 5, and 6, when the change was happening to the x-axis, that it went the opposite direction that we were expecting. In number 4, it says x minus 2, but it goes 2 to the right. In number 5, it said x plus 3, but it goes 3 to the left. And in number 6, it says x minus 1, but it goes 1 unit to the right. So remember that x lies in the equation. Now, the rule, when we tell what is actually happening for the translation, we always tell the truth. The actual graph is moving to the right. The actual graph is moving to the left. The actual graph is moving to the right. But in the equation, x says the opposite. It says minus 1. Here it says plus 3. And here it says minus 2. So the equation lies. This says minus, but it moves to the right. This says plus, but it moves to the left. This says minus, but it moves to the right. So remember, x lies in the equation. It does not tell the truth. The translation rule always tells the truth. The rule will never, ever lie. It's just the equation where x lies. Because let's go back up here to the top. In 1, 2, and 3, whatever was happening to y was actually what we saw in the equation. Plus was up, minus was down, plus was up. So I want you to notice the difference between 1, 2, and 3, and 4, 5, and 6. It affects x when it's in the grouping symbol with x. It affects y when it's outside of the grouping symbol. So if the change is inside the grouping symbol, it affects x. If the change is outside the grouping symbol, it affects y. Okay, so that's our difference there. All right, so let's look at example 1. So it's the graph of y equals x squared. That would be the parent function, is shown at the right. So here is y equals x squared. That's the parent function, together with its image under translation t. So the other graph here, this is my translated quadratic. So we're asked to find the translation rule for t. So let's see. I use my vertex, and I look at my vertex. It has gone 1, 2 to the right. So the translation rule would be x plus 2. The rule doesn't lie. The rule tells the truth. 2 to the right. And then 1, 2, 3, 4, 5 down. Y minus 5. I could also write this as t positive 2, comma, negative 5 as a subscript. All right. Letter B, find the image of 3, 9 under T. So just to clarify, we have pre-image. The translation rule happens, and then we have an image. The image is where did it move to. So the pre-image is 3, 9. The translation rule happens, and we get an image. So I could use the graph if I wanted to, but I'm just going to use the translation rule. It says that x is going to get 2 added to it, so my 3 is going to have 2 added to it, and it becomes 5. And my y is going to subtract 5, so 9 minus 5, that's going to give me 4. So this is my translation rule. Happens to the pre-image to give me the image. All right, letter C. It says find the equation for the image. Well, I know I start off with y equals x squared. That's my basis. Then I am going to translate it, and it says to add 2 to the x. But remember, the equation lies, so the x is going to have x minus 2. And then it says subtract 5 from the y. So that's minus 5. Right, so let's talk about how we wrote this equation. The first thing we did is we started with the parent. And then x lies in the equation. And remember, in the grouping symbol, which is why I put the x minus 2 inside of the grouping symbol. And y tells the truth outside the grouping symbol. So that's how I was able to write my equation. So let's title that writing an equation. Start with the parent. X lies in the grouping symbol. Y tells the truth outside the grouping symbol. Right, so let's go to example 2. Consider the equation y equals 1 divided by the quantity x plus 2 minus 3. Use the parent function to find the equation for the new asymptotes. Right, so if I'm going to find the equation for the new asymptotes, I first need to know the equation for the old asymptotes, or the parent asymptotes. So I'm always going to start with the parent asymptotes. And the parent function for this is y equals 1 divided by x. And our parent asymptotes are x equals 0 and y equals 0. Because this is the graph, it's going to look like that. Then I'm going to write down what my translation rule is. And my translation rule, let's see, I have x plus 2 in the equation, which means it's going to be x minus 2 in the rule. And to the y, I subtract 3, and y tells the truth, so that's going to stay y minus 3. I could also write that translation rule as negative 2, comma, negative 3. And now I'm going to write my equation for my new asymptotes. And my new asymptotes, I have x equals 0, And according to my translation rule, I subtract 2 from the x. So x equals -2 is my new x asymptote. Y equals 0. I'm going to subtract 3 from the y. So y equals -3. So here are my new asymptotes. Let's look at example 3. Consider the equation y equals the absolute value of x minus 7 plus 44. What is the coordinate for the max or min? Again, I'm going to start with my parent. Max or min. So I've got to ask myself, what's my parent function? It's y equals the absolute value of x. I'll make a little sketch of my graph. Okay, and it's obvious from my little sketch of my graph that my parent function's min, it's a min by the way, is 0, 0, that minimum value. I'm then going to write down my translation rule. And I look at this, minus 7 in the equation, so it's x plus 7. And plus 44, so that stays the same. I can also write it as 744. And then my new, or my, I'll call it my new max or min. Well, it's a min, because the original was a min. And I'm going to add 7 to the x, so I get 7. I'm going to add 44 to the y, so I get 44. So there's my new max or min. Every time you start with the parent, you use the rule, and you get the new. Parent, use the rule, get the new. It's even what we did all the way up here in this first example. We had the original, we applied this rule, and we got the new one. All right, so let's talk a little bit about things that translations affect and things they do not affect. The translations affect the domain. For instance, in absolute value, when the minimum value moves from 0, 0 to 744, that's going to affect potentially the domain. It could change what x or y can equal. Same thing with range. It can change its placement on the graph. It can affect the asymptotes. It can affect the max or min. However, the translation never affects the shape. If it's a V, it stays a V. If it's a U, it stays a U. It doesn't affect its size. It doesn't make it get larger or smaller. And it also doesn't affect whether it opens up or down. None of those things are affected. My quadratic at the top here stayed opening up. My absolute value here, my V, stayed opening up as well. The V stayed a V, the U stayed a U. This shape here even stayed the same. It just got shifted around on the graph, which is why it can affect the domain or range, placement on the graph, asymptotes, max or min.